Good morning, good afternoon, good evening, whatever the time may be at this glorious moment. As we are doing mathematics, we are back and we are better than ever. We are going to tackle constant velocity problems, and we are going to solve these problems using vectors. So, first, we are going to consider again the yacht in the opening problem. I think in order to consider it again, we had to consider it in the first place, which we didn't. So there she is. Okay, so a yacht club, the Becker Yacht Club, we'll call it B, right there, is located at 0, 0. And at noon, a yacht is at point 220. Point A, 220. There she is. The yacht is moving with constant speed in the straight path shown in the diagram. The grid intervals are kilometers, so all of these guys are kilometers. At 1 o'clock, the yacht is at 6:17, and at 2 o'clock, it is at 10:14. And we have that same diagram sort of here, but let's take a look at it. The initial position of the yacht is given by the position vector 220. So let's just review position vectors real quick. It's a good opportunity to do so. So if I have a vector 220 and I start at the origin here, so I would go over 2 and then up 20 there, then the resultant vector, remember adding vectors geometrically, gives me the position. There it is, right there. That's the position vector. The direction of the yacht is given by the vector b for -3. Well, that's easy. Over just starting at this 12 noon point, horizontal 4, 1, 2, 3, 4, down 3, 1, 2, 3 to get to point B. So that makes a lot of sense. Suppose that t hours after leaving A, the yacht is at RXY. Okay, so we're at some point RXY. Now, if you just look here, this vector right here is given by the position vector plus the directional vector. This plus this results in the vector OR. So OR equals OA plus AR. Look at that. OA plus AR gives me the vector OR. We've been doing that for years now. Just replacing with what we know, the resultant vector R, blah, 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 220 positional vector, multiply by the time t and the direction, t greater than or equal to 0. Then we can replace the R with xy. Both of these are vector equations of the yacht's path. And that's summed up nicely here. If an object has initial position vector A and moves with a constant velocity b, its position at time t is given by r equals a plus tb. This, boys and girls, is still our general vector equation given to us on our wonderful formula sheet. Okay? The speed of the object is the magnitude of b. I just want to point out a couple things. This is A is the initial position. B is the velocity vector is what we call it. Okay? And if we want to get the speed, all we have to do is take the magnitude of the velocity vector, which makes perfect sense because that's what we've always done to find the different ways to, or to find like the force or the speed or whatever. Okay, I'm changing this because it just makes my life easier to have it. That's the way I know it. Okay, so let's try a problem. This vector equation here gives the path of an object. The time t is in seconds, t is greater than or equal to 0, and distances are in meters. Find the object's initial position. Well, if you remember from the previous page, we are in the general form r equals a plus tb. And so the easy answer to that is, well, it's the initial position vector, the position vector. It's at 1, 9. Okay? It's that's the position vector, and that gives the ordered pair 1, 9 because they asked for the position, not the vector. So if you give me that, it's wrong. This is correct. The initial position happens when t is equal to 0. So the other way to think about it is let t equal 0. That multiplies by 3, negative 4. And we're left with 1, 9. Okay. So plot the path of the object for t equals 0, 1, 2, and 3. Okay, so for t equals 0, we already have, oops, that's not 0. Ooh, I just messed that up too. Here, hold on. Hold the phone, I can fix that. Okay, and boom. All right, we at t equals 0, we have the point 1, 9. So that's up here. For t equal to 1, replace 1 here. 1 times 3, 1 times negative 4. So 1 plus 3 is 4. 9 and negative 4 is 5. And that gives us the let's see, what, 4, 5. 1, 2, 3, 4, 5. Okay, so this was at time equals 0. T equals 0, t equals 1. Then it's just, we just figure out all the, after plugging in these numbers for t and we add. I'm not going to go through doing that. I'll give these to you. The next, for t equals 2, we're going to get 7, so let's see, 5, 7, 1 right here. That's t equals 2. And at t equals 3, we end up at 10, negative 3. So that's t equals 3. Okay. And so, let's see, the path is given by this vector. Let's change the color so we can still see the points. We'll make it black. And there we go. That is the direction of the yacht and its position at different times. Look at this position vector, 3, negative 4. Over 3, down 4. Over 3, down 4. Over 3, down 4. That's the other way we could have found those points without doing the algebra. All right, C, find the velocity vector of the object. Velocity vector is B, direction, velocity. It's serving another purpose here, but if you think about it, it's really the same thing. So let's see, the velocity vector is 3, negative 4. Okay, the velocity, or find the object's speed. Well, that's going to be the magnitude of 3, negative 4. So that would be the square root of 3 squared plus negative 4 squared, which turns out to be root 25, which is going to be 5 meters per second. Okay, and then E. This is, we have to think just a little bit here. If the object continues in the same direction but increases its speed to 30 meters per second, state its new velocity vector. So the speed was 5, but now it's going to be 30. Okay, so let's think about that. It's gone from 5 meters per second, and it has increased to, or changed, let's just say it has changed to 30 meters per second, which is 6 times faster, or as fast, right? It's 30 meters per second is 6 times faster than 5 meters per second, okay? Well, all I have to do, and it makes perfect sense, my velocity vector must increase by 6 times as well. It must be 6 times as great. So I just have to take 6 multiplied by 3, negative 4, and that gives me the velocity, the new velocity vector of 18, negative 24. Okay? And one way you can check it, if you're paranoid about it, is the magnitude of this must be 30 meters per second. And I just happen to have my handy dandy calculator here. And so we'll check her out. So let's see, square root 18 squared plus, boom, negative 30. No, why do I, not 30, negative 24. 24 squared, and that's going to equal 30. There we go. So we know we're right. Okay. All right, one more example, and I will be quiet. It's not that difficult. An object is initially at 5'10", and moves with velocity vector 3I minus j meters per minute. Unit vector form, I'm going 3, negative 1, and put it in component form. Find the position of the object at time t minutes. Not the initial position, the position of the object after a specific time. Okay, so we know r equals a plus tb. So that means xy is equal to the initial position, 510, plus t times the velocity vector, which is the direction, 3, negative 1. Okay. Now, key point here. This is a vector equation. This asks for the position. So the position is always a coordinate. The x-coordinate is going to be equal to 5 plus 3t. Got that right here. And the y-coordinate will be 10. T times negative 1 is negative t, so that will be 10 minus t. Easy peasy pumpkin pie. All right. B, the speed of the object. Easy. Magnitude of the velocity vector, 3, negative 1, is going to be root 10, and I forget our units already, meters per minute. So that's meters per minute. That looks a little weird, like an odd millimeter thing. All right. C, the position of the object at t equals 3 minutes. Well, that's just replacing t here to get our new coordinates. Replacing t with 3. Again, position, so we're going to get an ordered pair. 3 times 3 is 9, plus 5 is 14. Ooh, awful, 14. 10 minus 3 is 7. All right, D. The time when the object is due east of 0, 0. Well, let's think about that. The object is due east of 0, 0. Well, here's 0, 0, the origin, right? And this would be due east. And it starts at 5, 10, just taking a guess. And it goes over 3, down 1. So it's going this way, right? So it's asking the time when it's here. Well, I do not know what the x-coordinate is, but I certainly know that the y-coordinate is 0, right? And I also know that y is equal to 10 minus t, right? So if 0 equals 10 minus t, replacing y with 0, then t equals 10. So the answer would be it's due east, or on the x-axis, after 10 seconds. That is it. I am out, and we shall see you next time.